Alright, so students, for today's video, we are going to start with our chapter 8, which include the topic integration. Okay, so for today's learning outcome, or maybe after this whole session, this whole chapter, you should able to actually do some very basic integration. Use the basic rule of integration, and after that, you need to understand that integration is the reverse process of differentiation. All right, and then after that, you need to use your integration techniques and rules to solve the problem. Okay, that involve all these. Okay, solve the problem that you need to use the integration one. All right, okay, so this is already the last chapter in pure maths for AS syllabus. All right, so you'll see that actually all the topics in AS syllabus is not really hard for you to understand. Right, but again, I want to say is that you have to really make sure that you understand all the concept and also you try a lot of A-level partial questions. Okay, right. So let's start with integration part. Okay, so before we start, another thing to tell you is integration usually will also give you quite a lot of marks. Okay, in the real exam, differentiation and integration, both chapters usually they carry a lot. So just make sure that you are really clear about this whole chapter. Right. Okay, so let's start with the basic rules of integration. Okay, so for basic rules of integration, there are a few here. I can just discuss some very simple example with you. Right. Then only we go through the harder examples later. Right. So first, when you want to do any integration, right, you will always see this sign. This is the integration sign with dx at the end. Integrate something dx, integrate something dt also can, but generally for us we are using x. Right? Okay, so if let's say they want you to integrate a is a number. So integrate a number towards x is equals to ax plus c. That means you just try to add some x at the back of the a. Okay, so it is the reverse way of differentiation, and that means you should know. Okay, if let's say I differentiate ax, you'll get an a. So this is the a. Differentiate ax, you get an a. That means your answer is correct. Understand or not? It is a reverse. Okay. Reverse process of differentiation. Alright, so if let's say I'm having dt here, then when you want to integrate a dt, that means you're having at plus c. Alright, so all these are very small details that you should know. Okay? Alright, so this is the integration sign. And you should know also from y, when you want to get the dy dx, we use differentiation. In previous chapter, right? Differentiation. Okay, and then you need to know that if let's say you're having dy dx and you wish to get the original equation y, then you are doing the integration. Alright, so this is a very important concept that you need to know. There's a link between differentiation and also integration. Okay, so if no problem, then we'll start. If let's say we are having integrate, I want you to integrate negative 5 dx. So what do I have? I will have negative 5x then plus c. So please take note that the plus c here is a number that you don't know yet. Alright, usually we'll put it at the end of the integration. Indefinite integration, that means because if let's say you look at the whole thing here, if you do the differentiation, differentiate a c, you'll get a 0. So it will not be shown here. That means there's a possibility that you should have a number here. Alright, but we don't know what is number, then you should not as a c. Okay, so as an example, if let's say I want you to integrate 1 over 2 dt. So what do you get? You'll get 1 over 2t then plus c. So I think the very first basic rule here is very easy. Okay, right, should be no problem for all of you. Okay, then now we continue to the part number 2, the second rule that we are going to learn. Okay, so for the second rule that we are going to learn is when they want you to integrate x power n, then what's the step? So it should be x power n plus 1 divided by the new power n plus c. Okay? And then you just remember always that it is the reverse process of differentiation. So differentiation is what? Your power minus 1. Right or not? Then you multiply the power. That means you multiply and power put in front, multiply, right? And that power minus 1. So this reverse way is the power plus 1 first, right? Then you don't multiply, you divide it. Alright, so it is the opposite process of differentiation. Okay, so integrate x power n, you have n plus 1 divided by n plus 1, then plus c. Okay, for all the values of n except n equals to -1. So we'll discuss on this later. Alright, so let's talk about some simple example. Let's say I want you to integrate x power 2. So what do I get? I'm having x power 3 power plus 1 divided by 3, then plus c. It looks very simple, right? Okay, so if let's say I want you to integrate 1 over square root x. So what do I have? So before you do the integration, you have to change the term into the x power n first. So if you change it become x power n, it is actually x power -half. Again, then dx. So what do I have? Again, power plus 1 become half divided by the new power and then plus c. So if you simplify further, then you have 2x power half then plus c. Okay, so you cannot tell me that, oh teacher, I integrate the one on top, integrate this one at the bottom separately. Can or not? Cannot. Right, you have to change it. It becomes a pattern that you can integrate them. Alright, so this is what we have for the second rule. Okay, then now why we cannot have n equals to -1? So we just take one example. 1 over x. If I want you to integrate 1 over x, that means what? That means it is x power -1. If you're having x power -1, can I use the method to solve the integration or not? You can try. Okay, so -1 is your power, then you have to plus 1, right? It becomes 0. Then it divided by 0, then plus c. So when anything divided by 0, it is actually a math error. So you won't have any answer here. Alright, therefore, the n equals to -1, power x equals to -1, x -1, you cannot get the integration for now in AS level, but we will learn this integration in A2. Alright, okay, so this is the second rule that we have. So I hope that you understand how we get it. Alright, then now the third one. So for the third one, when you are having a constant multiplied with a function of x, when you want to do the integration, you can pull out the constant first, then only integrate the function fx. And this is usually the method that I would strongly suggest students to do it. Okay, because sometimes when you take out the constant and integrate it, the function or maybe the step can become very simple. Right? So maybe I just show you one example here. Okay, so let's say I want you to integrate, let's say, so 3x power half. Okay, so to integrate this, I'm having a constant multiplied with a function. Alright, so for the integration, I prefer to take out the 3 first, and then I only focus on x power half. Okay, so for x power half, you have x power 3 over 2 plus 1, alright, then divided by 3 over 2. Okay, then plus c. If you continue simplify it, you should be able to have 2x power 3 over 2 plus c. Okay, so maybe you will say that this one seems like no difference, but the step is still very simple. Yeah, I agree. But if let's say you go to A2 level, you will see that this technique is very useful, because if you take out a constant, you will get the idea, or you will see that, oh, the integration can become very, very simple. Alright, so maybe I show you another example. Okay, let's say I'm having 1 over 10 x squared minus 1 over 10 x power 3. Okay, so this whole thing, if you look at it, you feel like, oh, okay, got 10 at the bottom. So how are you going to do it? So for me, I will suggest you to take out the constant first. Take out 1 over 10. And then you integrate 1 over x squared. Okay, so 1 over x squared is x power -2. Then this one is x power -3. Then only you try to do integration. You take out the constant, then only you focus on integration. -2 plus 1 become -1 divided by -1. -3 plus 1 become -2 divided by -2. Then plus c at the back. So you will have 1 over 10 negative 1 over x plus 1 over 2x squared, then plus c. So this is how we actually apply this rule. You take out the constant first, then only you do the integration. Alright? Okay, so I hope that you understand for all these basic rules here. And then now proceed to the fourth one. So the fourth one is talking about when you're having two functions with sum or subtraction between the two functions, you can integrate them separately. Alright, so as an example, if let's say I have the integration of 1 minus x power 5 divided by square root x. Let's say. Okay, so this is a fraction, right? So you cannot straight away integrate a fraction by dividing it by looking it on top and also at the bottom separately. So you have to try and split it become two different functions in x. So how can you do it is you can split it become 1 over square root x minus x power 5 divided by square root x as well. Then further simplify it, you have x power negative half. Okay, then minus 5 power negative 5 minus half. You should have 9 over 2. Then only you integrate these two separately. Alright, so this is the meaning when you are having any fraction or whatsoever, right? You have to split it become two functions in x, then only you can do the integration. Alright? Okay, then last one. Okay, so for the last one here, okay, saying that when you're having a bracket with ax plus b inside and power n, when you do the integration, what is the step? You need to copy the whole bracket, power plus 1, like what you did just now, right? X power n, that means n, you need to plus 1, power plus 1, divided by the new power, and you need to divide it by a. Okay, so maybe some of you will ask, how can I get the a? So the a, actually you get it from here. You do the differentiation for ax plus b. So ax plus b, when you do the differentiation, you get a, right? So you divide by a. Because for differentiation, when you want to do the differentiation for this kind of bracket, right, you need to multiply the differentiation of the thing inside the bracket. But now you need to divide the differentiation of the thing in the bracket. Okay, it's divided, not multiplied anymore. So the a here is actually coming from the differentiation of x plus b. Okay, and then of course you can have a plus at the end. Right, so again, for this kind of rules, it is not applicable for n minus 1. The reason is the same like what I showed you just now. If you have power negative 1, when you divide it, it will become divided 0, which is a math error. Alright, okay, so let's see how are we going to apply this kind of example, this kind of rules. Okay, so let's say we take a simple one. I want to get the integration for 2x plus 4 power 3. Okay, so how can I get the integration for this? So again, you copy the bracket. Power plus 1 become 4 divided by the new power 4. And then you do the differentiation for 2x plus 4, you get the 2. Okay, then plus c at the back. Therefore, you should have 1 over 8. And then 2x plus 4 power 4 plus c. So I think this is not hard, right? Okay, right, so we try another one. How about if let's say I'm having 3 divided by square root and then 1 minus 4x. Okay, so for this integration, 3 is a constant. So again, for me, I might want to take it out as a 3. And then for the power at the bottom, I would like to take it out, become 1 minus 4x power negative half. I hope I didn't do any kind of mistake here. Right? Okay, then what do I have? 3 is a constant, therefore I just copy it. Then for this bracket, I copy the bracket, then the power plus 1, which is become half, divided by the new power. Then I do the differentiation inside this bracket. Differentiate 1, you get a 0. Differentiate negative 4x, negative 4. So you put a negative 4 here. And then plus c. So eventually, I think you should be able to get negative. That's a 2 at the bottom, right? 3 over 2. And then 1 minus 4x power half. Then plus c. Okay, so far any problem or not? Okay, so if no, then I want to ask you one question. Okay, so if let's say I'm having this integration, let's say I'm having x squared plus 1, maybe x squared plus 2, then power maybe 2. Okay, so how can I do the integration for this? Alright, so if let's say according to the answer, to the rules that we get, it is copy the bracket, power plus 1 become 3, divided by the new power 3. Then after that, you differentiate the thing inside the bracket. Differentiate x squared, what do you have? You have 2x. Differentiate 2, you get a 0. So plus 6. Okay, so eventually you will get this. Okay, so do you get this answer in your mind? Okay, if yes, congratulations, your answer is wrong. Alright, so maybe you're thinking, why is it wrong? Hey, I follow exactly the steps, okay, but why can I get a wrong answer? Okay, so generally it's like that. For any formula that you want to apply in integration, right? You have to be very particular with the patterns of the question. Right, so if you look at the formula again, this method you can only apply for the pattern ax plus b. So what's so special about ax plus b? The x here must be power 1. Power 2, power 3, power 4, and other power, you cannot apply this method here. There are some other methods that you can use. Understand what I'm saying or not? So it's very particular one. You have to check the pattern very, very carefully. So if I look at this example here, I'm having x squared plus 2. It is not power 1 anymore. Therefore, you cannot apply this method. Understand? All right. Yeah, so if let's say in exam they give you this kind of question, how are you going to solve it? Okay, so if you are having this kind of question, then what you can do is like you expand the bracket first. Expand it become x power 4 plus 4x squared plus 4. That only you integrate term by term. So x power 5 divided by 5 plus 4x power 3 divided by 3, then plus 4x, then plus 6. This is the correct way. Okay, so when you want to apply all these rules, you also have to be very careful. All right, especially for integration, because for integration, they are really, really particular. So again, this kind of method, again, what I want to emphasize here is, it is only applicable for the bracket with ax power 1 plus b in the bracket. If you got any other power or any other patterns, generally you have to find other way to solve it. But for this one, you have to expand. Okay, so far any problem or not? Alright, so these are all the basic integration rules that is covered in A-level syllabus. So again, you say it is not hard, I understand. Alright, but all the basics here are very important. Okay, so I hope that you remember all this. Okay, then after that there's a remark. So I think remark, most of you should know that when you're having multiplication of two functions, it is not equals to integration the first one multiply with integration the second one. Cannot. You have to make it into something plus something or something minus something. Then only you can integrate. Right? So for fraction also the same thing. You cannot tell me I'll integrate something on top, something at the bottom separately. Cannot. Alright? Okay, so don't know whether you understand or not, but I think it's time for you to try. Okay, I will leave all the steps, detailed steps for you in, for example 1 and 2. You go and figure it out yourself. Alright, it is generally applying all the rules that we discussed just now. Alright, so for example 1, the answer for part A is plus 1 over 8 x power 8 minus 1 over part A. Alright, and then for part B, this one is basically to check whether you know the very basic integration rules or not. Of course, in the exam, they seldom ask you this kind of question. Too straightforward already. Alright, and too simple also. Okay, then for example 2, the answer for part A and then the answer for part B and the answer for part C. Alright, so please complete example 1 and 2 yourself and then double check with the final answer here. Okay, alright, so make sure you know how to apply all the basic rule, and then for the next video we are going to discuss how we use the integration to solve problems. Alright, okay, so that's all for this video for today.